I'll take. No more blur. Here we go.
I think that's better. Do you think that's better, Bruce?
Yeah, well, you keep on popping out. You're fading,
Right. People were teasing us about having passed over the other night. They're saying, say hello to my folks on the other side.
Right. Yeah. No shortage of let's see, what do I want to do here? I want to go to the start. Oh, I know what I want to do.
Well, we were hoping
Here.
that Aleph was going to show up. She seemed so
Yeah, we must have scared her off.
enthusiastic.
oh, you
She
never
came in
know.
late last week, didn't she?
Not that late. We'll catch her if she shows up. We'll see it.
Right.
So we've got here 5 years of Aleph Talks now. This lecture actually might turn into 2 lectures. We kept staring at it to summarize everything, and it might spill over, but we'll see.
We're tossing around the idea of doing something over the summer, as we used to when we began, and then we took the summer off. What would your vote be, Bruce?
Oh, well, whatever you guys want to do.
Well, we could probably do one more lecture now, given what we've got in this thing. We probably won't cover all the summary here.
Oh,
So,
okay. All right.
Or we could add something else if
yeah.
there was interest. And we love having you here. We appreciate your presence and contributions, even though we're not Buddhists.
We do meditate every day. So here's what we've got on our picture here. Down here in the bottom right is our logo that Marjorie did a wonderful job on.
Oh, you don't have to say that.
But it's true. So we have the Hebrew letter Aleph here, and Aleph in mathematics denotes infinity. So Aleph, infinity, goes from alpha to omega, the start of the Greek alphabet, alpha, to the end of the Greek alphabet, omega. So from the start to the finish, infinity. It covers everything. And then we've got this, it's a dragon, I guess. It's eating its tail here. Here's its mouth on its tail, and you can see some wings. So it completely encompasses everything.
Right.
That's an alchemical symbol of infinity.
The dragon is
forest, swallowing its tail specifically.
okay. Good. And then over here in the bottom left corner, we've got an abstraction of the tree of life of the Kabbalah. So there are 10, 1, 2, 3, 4, 5, 6, 7, 9, 10 of these planes here. And there's, I would say, earth or something that's grounded down here, and then the heavens up here. What would you want to say?
Well, the top three are called in Kabbalah the three supernals, and they're kind of in a class by themselves. So some people would have left the top three of these bars off, but he's emphasizing that they also stand on their own. And he's showing some of the sacred geometry. This is used in Christianity, the Vesica Piscis.
The fish.
The fish. But it comes from this concept of the two overlapping circles. And so the top one is the first stage of the creative process, which I just want to emphasize, they know full well is an illusion. It's an illusion of the separation from the unity. But they celebrate the illusion of duality because that's where the interplay occurs. Otherwise, they would say it's just this one blob of unity. It's just this big jar of mayonnaise where nothing can happen. So without the Simsum, which represents that first stage of separation, the creative process in Kabbalah is a process of subtraction from the totality, from the unity. It's a division. It's not addition and multiplication. So you're differentiating from that absolute unity into this apparent separation that they would just say is where the interaction occurs. I use the word interplay. And I ran into this painting for the first time. It was, I don't know, about 5 or 6 feet tall in a gallery in Vermont. When I had gone up there, are we recording?
Yes.
Okay. I had gone up there in anticipation of, I did not know what,
Hold
but
on.
something was telling me to get out of Dodge when I was in New York in the year 2001. And in the spring, I went up to
Yeah,
Vermont.
we're recording.
And for quite a while, I brought my Kabbalah teacher up there. He gave classes. So anyway, I was just astonished to turn a corner in a gallery, and there, larger than life, was this beautiful painting, I thought. And I thought, is that Kabbalah? Is he talking about Kabbalah? And then there were a few more that convinced me that indeed he was. And it turned out he was also a Buddhist meditator. And he was discouraged from painting in the lineage he was studying. And because it's not simply contemplating the infinite unity of the universe. So that was actually why he ended up not remaining a Buddhist student and practitioner. We had him give a class. He gave a lecture, which we recorded, which we thought was interesting. He's a very nice guy. He's given us permission to use this image. We use it to anchor our website. And then it shows the idea of Kabbalah is this bolt of lightning comes from the divine and creates on earth. And what I like about his representation here are the stars and the universe, but this blacked out butterfly shows that it's a constant rebirth as well. So we come from this unity into separation, which can be seen as a death or a birth, and then it's happening constantly. So the butterfly is always being reborn, which I like, and he shows. That's, I think, like a representation of the table of elements, right?
Yeah.
And the constellations around it. So we have this blown up as a poster that we meditate with a lot. And we're grateful to blanking on his name.
Richard Stoddard.
Richard Stoddard, for allowing us to use it as part of our imagery.
So those are we've gotten the logo, we've done the tree of life here. Ron looked into
Say who Ron is.
Ron Cowan, who is Bruce's brother, but
Identical twin brother.
identical brother.
And they were both Buddhist meditators, Mooders.
But Ron, unfortunately, has passed on, and it's 2019, isn't it? Like August 2019.
Yeah.
And but while I worked with him for 3 years, he did a series of observations and came up with this geometric representation of our universe, which is 26 real dimensions. I'm just trying to think of how to show this.
So he was a Buddhist monk and a physicist.
Yeah, he was. Yeah, he was a he taught high school physics, and he wrote several books that are still in print. You can get them on Amazon, and we'll come back to what he did. But I just highlighted here that he realized there's 24 spatial dimensions, real spatial dimensions in the universe, but we only see 3 of them. And then there's the thing that's different is that another 3 are perpendicular or orthogonal to our 3 dimensions, and that's probably where your soul resides, or your guardian angels, or whatever you want to think of. But they'll be etheric beings that are there, and then that leaves, so that takes care of 3 dimensions that we live in, 3 for your guardian angel. That's 6, but we've got 24. So the other 18, it turns out, are broken down into 3 subspaces, each of 6 real dimensions. And we tie into 6 of those dimensions, and our guardian angel ties into 6 of them. And then there's a linkage between them with another 6 dimensions. And these are really these dimensions are real, that they're what are called compactified dimensions that we'll come back to in a bit. And when we get into our review, the point is that if we have 18 dimensions there, Ron observed that we had 3 holes in the compactified dimensions for matter, and we had 4 holes in the associated compactified dimensions for your guardian angel, or what becomes dark matter. And so that's 7. And then the linkage has 8 holes. So what's going to happen here to connect everything is that 3 of the holes from our matter link up to 3 of the holes in the higher realm. 4 of the holes in the dark matter link up to 4 of the holes in the higher realm. And then the 6 dimensions that are there in the higher realm have a hole that connects 2 of the dimensions. So you have a total of 8 holes that are all linked in these 18 dimensions, which really means there's only 10 dimensions there. And the 10 dimensions match the 10 Sephiroth of the Tree of Life. So the Kabbalists, the Judaic mystics were onto something, apparently, in that they could see that our universe, the world around us, is not what we see, but it's in fact has these 3 dimensions that we see, another 3 for our guardians or dark matter, and then 10, which are all compactified. Who knows how they saw this? We're going to get to it.
I just want to say, here's a quick image of what Bart just described. These are dimensions within the dimensions
This
that
is
connect to the other dimensions.
yeah, this is actually a six-dimensional space, but we're only looking at, since we got a picture of it here, it only is showing 3 dimensions, 2 in the paper, and then some depth to it. Okay, so but you can see that there's holes in this. You can see there's very much holes. And since we're on this, the other thing that's on the cover page is Ron observed what an electron is. And an electron is shown as these 10 strings here, but there's energy vibrating inside them. And the energy is conceptually turns into a hard jelly. So the electron actually isn't a particle, it's an energy that's resonant inside these vibrating strings. But what's crazy about this is the energy vibrates, and there's a hole through the middle of the electron. It's here. So the electron actually is a torus going top to bottom here. And the whole thing is covered with blocks of information, which we'll come back to, that are coding all of these fundamental particles. And they control everything, and they measure everything that's going on in the universe. So this is all around us.
The electron is a beautiful image that Bruce's brother Ron drew, and this is from the cover of one of his books, and this is I don't know if it's just colored pencil or watercolor.
It's yeah, but it's the crown chakra.
Yeah, representation of the crown chakra, which this is kind of cutting off,
Right.
but
Right.
they're just beautiful renderings.
Yeah, the key thing that Ron did here was other people have zoomed down under deep meditation into the microcosm, and they've observed like an electron, but it's vibrating like crazy, so it looks like a cosmic blob. It's going gung, 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 hundreds of millions of times per second. Okay, Ron was able to stop it, so he could draw these pictures. That shows you the power of his meditation, that he was able to control these forces to stop it, so that he could go do this. And by observing that there's 26 dimensions there, I just put up here, there's a classification that was just done after it took 130 years to do this, but it describes all the possible symmetries that are there in what are called groups in mathematics. And so there's a periodic table here that shows that there's 20 of these different categories of symmetries, but in the study of the symmetries, there's 26 sets of symmetries that don't match any of these up here. But 26 matches exactly the number of dimensions that Ron observed in what makes up the universe. So there's undoubtedly some linkage between those 26 symmetries and each of these different dimensions that we see around us. So truly mind-boggling what he came up with.
And two of the Western occultists and meditators who contributed to that periodic table were doing this kind of visualizing with meditation. Annie Besant and what was his first name? Leadbeater. Charles Leadbeater. And they ended up actually anticipating elements before they were discovered by Western science. But just by doing the math and formulating it this way in this form of this diagram, this chart, and seeing where the blanks were, they were able to figure out where they belonged and what their weight would be. And they had different names for them, but they definitely anticipated the discovery of these elements
Yeah, some of them were
many years
beyond
ahead.
uranium. Uranium is the last natural element, but they foresaw some elements that were beyond uranium, which are artificial elements that are not found in nature. So that's our short cover here for 5 years of retrospective. So you can see there's a huge, I'll just say, science dimension to this, tied to a mystic dimension or spirituality of the Kabbalah. So we now go to Marjorie.
So Bart has all these very formal academic credentials, but on the other hand, I was raised by two physics majors from Brooklyn College, and my father had gone to the Bronx High School of Science before that. And in many ways, I got my most significant education at home. And I was sent to public schools for the social education in a lot of ways. I went to college early. I went to the New School for Social Research. It was an accredited program. And I started, my freshman year was in place of what would have been my junior year of high school. So 11th grade was at the New School, and I transferred from there to Columbia, where I did, it would have been my sophomore year of college in place of my senior year of high school. So it didn't hurt, the public school, or anytime I asked my mother a question, she would say, I don't know, look it up. So that was my background, and I osmosed a lot. but I kind of had a resistance to mathematics and physics and science, and I was more drawn toward writing of all kinds, but the arts of all kinds. But a lot of the time when Bart talks to me about what's on his mind, it resonates. It's like an intuitive thing that I kind of sort of understand. Even though, and we tried to do this class as a debate initially, as two opposites, but we've realized we actually agree too much to do that. We would always end up laughing when we were trying to stage a debate, because we would start chiming in with each other. So we abandoned that plan. And we've decided that what we actually have together is synergy. And that this third thing seems to emerge between us when we really are at our best. I became, after floundering around for a long time, a Jungian astrologer. That really, I started in earnest at the age of 29, studying on my own, and realized I couldn't get the real technical stuff on my own. I was reading a lot of the ideas and concepts, and that was great, but I wasn't learning the mechanics. So I started taking classes with one teacher that lasted about a year. Then that fell apart, not on my part. And I ended up going for 3 years with a former teacher on his faculty. She was also teaching privately. So my first teacher was a partner of Robert Hand back when they were in New York. And then Robert Hand went up to Cape Cod. But they were two of the founding fathers of using computers, personal computers, for the calculations. So astrology, really wouldn't be what it became without them. So I'm grateful to my first teacher, but my second teacher really got me going, and was just wonderful for me personally. She was extremely intelligent. She had been an abstract expressionist painter for many years before she became deeply engaged in astrology. And she was also a Sufi practitioner and a devoted, pledged Sufi. They fully surrender to a master when they do that. And she was also a very active Quaker, which is close to my Unitarian background. But very mystical. Her Sufi master suggested strongly that she get rid of all of her Western esoteric books. And so she gave them to me. And she became my mentor, and I became her protege and got private mentoring from her with her practice. I helped her prepare charts and things like that. And she bequeathed a wonderful beginning library to me of the Western esoteric tradition, because her Sufi master didn't want her to have it anymore. But she didn't burn the books. I added, after 3 years of that, I felt that there was so much truth in what could be said. I wanted to be sure I was saying it in a helpful way and not a hurtful way, and in a healing way. Because I think it can be, because it is so truthful, it can be very challenging. So I went for 3 more years of study in what was a kind of informal therapy training with a spiritual aspect to it. Most of the other students were already trained therapists of some kind or another. And I was one of the few who wasn't. And they were adding this spiritual dimension to it. And they would often find one teacher and instructor who they chose to follow closely. And I did that with the resident Jungian instructor, who actually was Swiss, from Switzerland. And he was very big at the Jung Institute itself. And he also taught very ecumenical, open-ended continuing ed classes at Cooper Union, which I always went to. And he did a wonderful series on Joseph Campbell's series at Cooper Union, where he answered questions in particular as if Jung was answering them. So he would usually take the time to say, well, this is how I would answer it, but I think this is what Jung himself would say. So that was really wonderful. And I ended up in a private study group with him, with my friend Royce, who was a student at the time. He's now on the faculty of the Jung Institute. And he came and gave a guest lecture for us, which was, I thought, really great. So he did the whole Monty, and he was ordained and also became a fully recognized PhD psychoanalyst. I became ordained in a far less formal training after 1 year. That was in 2005. It was in the Divine Feminine. And we did a lot of work with Labyrinth in that year. And I was ordained in 2006, which was the same year that I got my Labyrinth facilitator training. I had worked with Labyrinth since the 90s.
That's over here.
Okay. So I had been doing astrology for a few years when I added another layer of tarot. And the tarot really comes out of Kabbalah. So it was good that I had that introduction. I studied tarot before Kabbalah. And then when I studied Kabbalah, which was at the Theosophical Society, the teacher had a secular Jewish background and he was a painter. But he studied with a Hasidic rabbi out in Brooklyn in a neighborhood called Crown Heights, which is the perfect Kabbalah pun, because it's the equivalent of the crown chakra that is the top. They call it a sephirot, which is sphere of the tree of life. We should have a standard representation of the tree here. We don't. And so he was really instrumental in my life. And he had been a painter I've always known a lot of painters. I think it's one of my frustrated lost selves. My father painted too. And so he studied at the Rhode Island School of Design as a painter. So it seems like every 5 years or so, I add another layer, which I didn't understand for quite some time. I started studying Reiki in 2002. I really did that to be able to give that to my father on his last months. And I did it for every day for, I forget, the last 5 months of his life, which was very deep. I mentioned getting labyrinth training with the founder of a organization called Veriditas, which comes out of Hildegard's work. And she came to Connecticut. It was really like a gift just for me that she came to. It was actually a Catholic retreat center north of here on the water. And that was a retreat training that I was able to commute to. So my mother was at home after her stroke, so I could go back and forth and have help come in for her. And that was really wonderful. And I became a presenter in a CD that they made. They invited me to do that. And Lauren really approved of what I was doing with combining what's called sacred activism and mysticism. So using the labyrinth for peace, and we would do things like introduce a theme like the situation in Darfur and send solar stoves to Darfur as our sacred activism after the labyrinth walk. When I finish a labyrinth walk, I always want to do something positive for the world and not just go back to, road rage as usual. And so that's why I did that, and I was able to found a program at the Unitarian Church where I started this. They called it a program of sacred activism. It was part of the social justice work. And I was also involved in interfaith work from that. So I've been doing labyrinth walks at the church on and off. And since Bart has joined me, we've been doing it steadily for 5 years now, but since 2006, and try to do it for every equinox and solstice, which that happens 4 times a year. So we named this program, which we started at the Unitarian Church, AlephTalks. That was Bart's idea as a play on TED Talks, or the Hebrew letter Aleph, which stands for infinity rather than alpha, the beginning. And it means the beginning within the end and the end within the beginning. And I just think it's graphically beautiful as a letter. I used to do typesetting and graphics, so I really appreciate it that way. And all the Hebrew letters are said to represent flames behaving in different ways. They're energy. They're seen almost as entities. And in my Kabbalah class, we would spend weeks, several weeks on each letter of the Hebrew. They don't call it the alphabet, they call it the alphabet. And so Aleph was definitely my favorite letter, and if you can have such a thing. And I liked it because of Bart's work with mathematics and learning that there are actually many infinities. There isn't just one infinity or one kind of infinity, but mathematicians consider many kinds of infinities, and there are even a few alephs. So there have been layers upon layers, and we realized in our early dialogues, where we were thinking about doing this as a debate, here's the kind of thing that we had in common and why it was impossible to debate, because we just agreed too much. It was too artificial when we tried to stage it. Whoops. So I wish we could just bring this down a little bit. This book is called Hamlet's Mill. You can't see the Hamlets. And the Tao of Physics and On Growth and Form are 3 wonderful, wonderful books. And I would say they were definitely seminal for me. Would you say that for you?
Yeah, they're very out of the box thinking and research, and the ideas they present are really fundamental.
And I would say they were life altering for me to encounter all of them. I first encountered the Tao of Physics in my teen. Bart was in graduate school, so I'm sure he knew what to do with it much more than I did.
Well, when I was in graduate school, at that time, the physicists that were around me were all thinking that in just a few more years we'll have all the physics wrapped up. That we're gonna have everything sorted out. There was it was an incredible time. A lot of great experiments being done in CERN, in Geneva, and a lot of theory and so forth. And this book was written by a physicist who said, actually, you're really not going to be able to get anywhere. You've got to include brand new ideas into physics. And I think you should look to the East, to the mystics in the East, the Buddha, the Hindus, the Tao of Lao Tzu, for the ideas on what really is going on there. And indirectly, what he was saying is you should be looking after consciousness as a piece of physics. Jung realized this. Jung, when he talked about there being an entity, he never used the word God. He called it a collective unconsciousness, or a collective unconscious that's all around us. And that was really what this Tao of physics was dealing with, was trying to get physicists interested in that. After 50 years, there's no interest in it. And they have gotten nowhere in 50 years. Since then, 1975, everything ground to a halt, as we'll see, and there really are no new fundamental ideas that have come into physics. But I think that's all going to change in the next several years, as a lot of new ideas are surfacing that have been suppressed, quite frankly. So
It's really similar to religious dogma, what goes on. I was a scientific and medical proofreader for years, and you know, it's incredibly dogmatic, and the way it works with the grants and how they're granted and how the proposals have to be done. There's just a lot of redundancy, and what is it? You know, they're just chasing their own tail and confirming.
When you write a research proposal, it'll go to a government agency and they'll send it out for review to your direct competitors. So everybody knows what everybody else is doing. And if you're doing something really different, then you better be prepared to really defend it, or not do that and do the same old that everyone else is doing. And so that's what's happened, is in order to keep the money flowing, people have just decided rather fight it. We'll just regurgitate same old, and get our money coming in.
So
Hamlet's Mill is an interesting cut on mythology, or to put it differently, what we thought were myths probably were true. They're not myths.
well, what this thesis is they weren't a couple, but a dynamic duo that actually were working at MIT.
In the humanities department.
In the humanities department. Is that the myths were shorthand mnemonic devices for remembering planetary cycles, and the geometric forms that they form, and the relationships, and you know, the story of Hamlet having to avenge his father's death. You know, that had to do with Jupiter and Saturn. You know, who would ever think that? But apparently it's an extremely old myth that came out of Denmark, and made its way through, you know, most of Western Europe. but there are other versions of it in other cultures and languages that show the same, that lend themselves to the same interpretation that they came up with. The book is like this thick. It's huge, and it's got lots of wonderful illustrations and images, and they try to cover a diverse cross section of cultures and religion, and I think they make a convincing case. It's very controversial in academia, whether it's legitimate or not. A lot of people feel it is. I feel they may not be absolutely right in every single case, but in general, I think it's
Mhm.
definitely applicable to what the truth of the matter is and what the ancients knew and has been forgotten. So I thought it was really interesting that we were both affected by that book. It definitely opened my mind to all kinds of things. And I always thought Jung must have read it and maybe even been influenced by him, but it was published after he died, so
Right.
he didn't. So,
He was probably aware of the myths and so forth
right.
that they wrote about, but he never, to the best of our knowledge, wrote anything up on it, anything remotely like Hamlet's Mill.
So it's a scholarly contemplation of very Jungian ideas, but other people have those similar ideas. My mother said when she was at Brooklyn College, there were a lot of people doing the same thing that Joseph Campbell became known for, and that he just popularized it. But that was kind of common thinking at that time in the early 60s. A lot of people were on the same wavelength and um, doing similar comparisons and inventories. So he, managed to popularize it, which is good. Um, so now physics
You want
is
to do the final, the Darcy Wentworth Thompson.
and then this is a fascinating book. Darcy Wentworth Thompson wrote on growth and form. And this is the current cover image for it. He was fascinated by things like the Fibonacci sequence. Not only that, but as it occurs in nature, which includes galaxies, and the solar system is a similar ratio. A spiral is always a ratio. It's different ways of looking at the same thing in mathematical terms or geometric terms. And he thought that this had far more to do with evolution than, maybe I should zero in on that on my paper on Darcy Thompson rather than Mercury retrograde. I was thinking.
Okay.
I think I came up with some really good images for it. Like honeycombs and things like that, and patterns in nature. Well, his conclusion was that rather than some kind of teleology of this divine striving toward perfection, which was a part of it, but rather than, nature as a designer with a slide rule and a protractor, it's also necessity. It's also just the way the geometry of nature works, whether we're talking about molecules or any kind of bubble or blood cells or anything. A lot of it is governed by forces like gravity, or the organism's own growth, or the plant's own growth is a force. It's pushing out from the seed stage, from the germinal stage to its growth. it's doing that in these patterns, whether it's leaves around a stem. It's not linear,
Yeah.
and there's a lot of math to the intervals, which is really interesting if you really think about it, that things are quote unquote governed by those principles, and that's what influenced a lot of evolution. It was simply these rules of physics that they had to follow.
So the thing to keep in mind with these three books is the Tao of Physics and Darcy Wentworth Thompson, Growth and Form, are showing that there's structure underneath
Right.
what you see around you, and the structure is probably layered. The structure is upon structures upon structures, and Hamlet's mill is pointing to this has happened in the past as well, but we seem to have forgotten this lesson that's going there. So the takeaway is, the mysticism that you encounter actually has underneath it a huge amount of structure, and that by itself is mystic. Why is there structure?
Yeah, it's part of the mystery. And I think it's where a lot of people get this idea about purpose. It's kind of hard not to think about that when you see the inherent patterns and structure that are part of everything. And it could be a beautiful flower, and it is a beautiful flower, but it's also extremely mathematical and geometric and structured.
Yeah.
And there's such a variety of them. It's mind-boggling. And then the weight of a bird's bones to that's a ratio
seashells
to right.
to how your ear works to all kinds of biological phenomena. So
And
petals on plants.
for us, this is it enhances our sense of wonder. The closer you look, the more fantastic it becomes. I mean, at times, to me, it's really psychedelic, but it's science, it's reality. We're noticing the patterns, but I don't think we're making them up. I think they're objectively there, and we're wired to become aware of them, which some other, beings may not be, but it's there, and that seems to be part of the divine mystery of it all, that to me is just enhanced by learning more. The more you learn, the more far-fetched it is, and the more miraculous it becomes. And I think that's true on the really microcosmic level of atoms and quarks and cells and
Everything.
as fine as you could go, and then as gross as you could go with what they're discovering since they've developed these really powerful telescopes as well as microscopes, that you see these incredible patterns, and they can measure light distances with a spectrum, and things like that. The more you look, the more incredible it is. And the more ordered it is, the less random it is. And I still think it's random, but it's a kind of organized chaos.
Yeah.
What else can you say?
Well, there's free will at work also that influences these things. We'll come back to that.
So it's complicated.
So
So we want to say we met at the Unitarian Church in about 2002, which is when I started going. Bart had already been going since the late 90s. And gradually we realized I knew that he had a science background and a finance background, which was kind of like this for me. There, can you see that? And then I've realized he was a really deep meditator and a yoga practitioner, which I hadn't known. And then this kind of thing started coming up in our conversations more and more. And I haven't met many people who've read any one of these books. And he's the only person I've ever met who's read all three of them. And I would say been influenced by each one. And for me, they were all, I would say, some of my deepest influences. And for both of us outside of academia, you
Right.
know, did you discover
No, they were all, I
how
found
much?
all these on my own.
Okay, that was the case for me too. Hamlet's Mill was actually recommended to me by an owner of an esoteric bookstore in New York. And he said, "You haven't read Hamlet's Mill? Everybody has to have their own copy. You're an astrologer, you need one. I'll give you a discount." And he had a used copy. They were out of print at the time, and he gave me a wonderful discount. And it was just an amazing gift. And I just couldn't believe that it was never part of any, you know, any science class or anything. And there's so much attention given to Darwin. And, most of the objections come from the religious end of things. They're not mutually exclusive at all. I think that's a false dichotomy. But I think Darcy Wentworth Thompson had a much better um, understanding of evolution. And he saw it as almost like geometry in motion. It was, and I have an essay I could share. He was a triple scholar. He was a classicist. He was a mathematician. And what was the third thing? Was it a naturalist? I think so.
Yeah.
And he spoke fluent Greek and read all the Greeks. He translated the Greeks and absorbed a lot of their ideas. They are all over the concept of ratio. That's like a, kind of a definitive Greek concept.
And the Greeks got it all from the Egyptians.
Right, that's
They
true.
didn't do it. So
But they influenced Western civilization. And but he, I think he was a wonderful guy and completely overlooked by history and literature. And there's
yeah.
a Darwin Society, and they have, you know,
Yeah, in the
gatherings
same
every
vein,
year.
the Tao of physics, Friedhof Capra was, a very strong theoretician, theoretical physicist, but he was hung up on a particular approach to how he thought things would shake out in the, mid to late 70s. And in fact, this alternative approach won, and the alternative approach is the one that's been in place now for 50 years. And people point to, well, he picked the wrong model in doing all this, and they miss the real lesson that he was raising here was you need new ideas. And in 50 years, they haven't gone beyond this 1975 model. They're just wrapped around an axle going nowhere. That was his takeaway,
Right.
not the particular model that it was. He thought they were all inadequate.
Well, then it becomes a dogma,
Yeah.
I think. That's what I saw in my medical and scientific proofreading, was that nobody dared rock the boat on the given dogma at a given time. So then we introduced Bart, who spent many years at MIT and received his PhD there ultimately in 72 in what's called applied mathematics. So you
Yeah.
want to talk a little bit about that, why that's different from
Well, electrical
other
engineering is one of the more theoretical areas of engineering because it draws on uh, a lot of mathematics, linear algebra, harmonic analysis, Fourier and Laplace transforms of all sorts. Uh, and extensions of those. And then just anything involved in electrical circuit theory comes out of it's actually a mathematical approximation to what happens in Maxwell's equations of electromagnetism is how electronic circuits get designed. And a lot of times when people push the envelope in circuits, they forget that, oh, this circuit model is only an approximation, and I should have gone back and used the actual equations of electromagnetism to come up with what's really going on. So that happens more and more nowadays. So while I was an undergraduate, there's a core curriculum that I had to take. So there's a basic introductory course in the foundations of electromagnetism that just surveys everything. And then I took two specialized courses, one in motors and generators and electromechanics. When you put a charge on a fluid, for example, and then put an electric or magnetic field on it, how does it behave? So that was one specialized area. And power engineering is a huge area of electrical engineering. And then the final third course was all in antennas and radiation and waveguides and coaxial cables and things like this. So
You can
I
see the future AT&T or Bell Labs scientists just in those initial classes. That
Yeah,
you
well,
knew where you were going.
yeah, well, Bell Labs was the national research laboratory for the phone system in the U.S. So, they dealt. You had to supply power to the electronics that were in the network, and you had to design, antennas. You look at those towers out there, you'll see antenna. Initially they were for the TV stations, TV networks, but now they're all for cellular, mobile, and motors show up in all kinds of different ways, motors and generators. So, so what I'm going to go through is I had an epiphany when I was in graduate school that was after all these undergraduate classes that I'd taken in electromagnetism. And then I had a meeting with someone who just called me up out of the blue and said, I want to have a cup of coffee, and ran through for me what I had missed in electromagnetism. And then I linked up with Ron and came up with even more stuff there. So this has all been cooking for quite a long time in particular. So let's just go back and do a brief review of electromagnetism. A lot of what people learn about this is due to Michael Faraday, who was a Brit and was an incredible experimentalist, and he was a great communicator. And so he carried out a series of experiments that led to four basic principles of electromagnetism. That first, electric charges attract or repel one another with a force that's inversely proportional to the square of the distance, and opposite charges attract and like charges repel. So keep that in mind. Like charges repel, opposite charges attract. Then we had magnetic poles, where you have a magnet, and he noticed that when he took a piece of paper and sprinkled iron filings on it, that lines appeared that were generated by the iron filings connecting head and toe to one another, that suggested that there was he called it a field, for want of a better term, that connected the North Pole to the South Pole. And so that's the magnetic poles. For example, the North Pole will attract the South Pole, but will repel another North Pole on another magnet. That's what you have to keep in mind. So then the third principle is an electric current inside a wire creates a magnetic field outside the wire. So when you run a current through the wire, there's a magnetic field that's generated, and the direction depends on, is the current flowing to the right to the left on the wire, or the left to the right, and you get an opposite magnetic field. And then finally, and the most important thing commercially is when you have a current in a loop of wire and you move it, remember it's got this magnetic field in it, then the direction of the current it actually gets induced by this movement. And this led to how you would design an electric generator to generate electricity. I would take something like water and have it spin a turbine, and I would wrap wires around the blades of the turbine, and then the net of it is the current would go through there, and it would have two sets of wires there, one that would have current in it, the other one would have an induced current in it. That's where we would generate electricity out of this. And when Faraday was asked about this discovery, which he thought was amazing, he said, he was asked, what good is it? And his answer was, I don't know what good it is, but I do know that one day you're going to tax it. And so whenever you pay your electric bill, you can point to Faraday for that payment. Now, one of the problems with what Faraday did in these four principles is they're all done at, I'll just say, low frequencies. So when he moved the current around in this wire, it was just by him moving it, an inch a second, something like that. Nikola Tesla in the 1890s was able to generate electricity at high frequencies, much higher than Faraday could do. The technology wasn't there. So hundreds of thousands or millions of times per second, he could have current flowing. And when he did this, he discovered that there were additional phenomena and additional terms in Maxwell's equations that Faraday had missed and Maxwell had missed. Maxwell simply was following what Faraday had done in experiments, so he's perfectly fine, but there's extra terms there, which we'll see in a minute.
Look at this mandala.
Yeah, this is a picture of an electric generator here, showing what's going on with the currents flying around. So in 1970, so you can see this is 55 years ago. Okay, that's how long ago I've been thinking about this. Roger Brockett, who is a Harvard applied math professor, and he was on my doctoral committee as an advisor, he suggested to me that I look at some work that a German called Hermann Grossman had done in the 1840s, and it was called exterior calculus. Now, I'd never seen this before, so I got out these books and papers and read about it. And what I discovered was the following, that when Maxwell put together his equations, there are several different vector operations that he developed to mathematically describe electromagnetism. So the first one is the gradient. The gradient, you could think of it, here's a plane, and it's flat, so the gradient is pretty much zero. But if I tilt it, now the slope is very steep. It has a very steep gradient. The rate of change is very great. So the gradient captures the rate of change of the function in each of the three spatial dimensions that are out there. So gradient. Then we come to divergence, where we look at a little volume of space and how do things flow out of it or how do things flow into it. For example, the electric, I could have some electric charge and therefore the electric charge would radiate out from it, or I would have some current that would be going into it, as an example, just divergence, a different operation. And then finally, the most complicated one is one due to rotation. It's given the name of curl. And when you look at a particular point, how are things rotating about that point? And so here we have these three things: gradient, divergence, and curl. I just taken 3 classes dealing with these different things here. And what happened was Grossman in the 1840s realized they were all special cases of an operation he called exterior differentiation. And he called it exterior vector calculus. So effectively, it's how to take the gradient of the gradient, or the gradient of the gradient of the gradient, and so forth. And I read this through, and then I followed up on what he said. And so we start off with what, according to Grossman, there's just a scalar function, a function that has is a function of space, x, y, and z, and you determine its gradient. When you take its gradient, you come up with what's called the potential, or more particularly a vector potential, because it's pointed into a particular direction, a vector. Now, when I take the gradient of that, the exterior derivative of that, the vector potential becomes the electromagnetic field. So the gradient of the gradient gives me my electromagnetic field. When I then do that one more time, the electromagnetic field gives me a current density. And when I take the gradient of that, the exterior derivative, the current density becomes the electromagnetic source, both electric and magnetic. No one has discovered magnetic sources, but since it's mathematics, you simply leave them in and say, oh, if we ever discover magnetic sources, here's where they'd go in these equations. So the thing that bothered me about this was that these equations have nothing to do with physics. It's simply Grossman saying you take this exterior derivative and run this through 1, 2, 3, 4 times, you get all of Maxwell's equations. But that's just mathematics. It has nothing to do with physics. But it gave you all of the correct equations that Faraday and Maxwell had developed, and many others. And there are some other relations that are called constitutive relations that couple, for example, current density and vector potential, which result in voltages and currents being related by resistance, for example. Or magnetism has a type of a permeability or susceptibility that influences the magnetic fields. But ignoring that, everything comes out of what Grossman did. And so this is disturbing to me, but I went ahead and summarized all this in a little block diagram that summarizes the 4 steps that I talked about on the previous chart. And this was because there was this French mathematician, Grothendieck, who was really popularizing this as a technique in mathematics. And so then I wrote this up as a Bell Labs memo, and it was published in 1974. So 51 years ago. So there were physicists and mathematicians at Bell Labs who reviewed this, and they all said, well, there's nothing new in this. And so I said, well, there could be nothing new in it, but I couldn't find any place in the technical literature where any of this was written down, and neither could they. So doesn't that bother you? Why do you say it's all nothing new? And especially for mathematicians, mathematicians deal in being very complete and precise. And for them to say there's nothing new, they should be able to point to a reference, but they didn't. So I left it. I just had that in the back of my mind for decades while life went on. So that carries me forward in time to what's this?
This individual wanted to be anonymous, so that's why Bart just described him as a brilliant individual.
Yeah, I got a phone call out of the blue by someone who had noticed some things I posted on a website. And so we had a cup of coffee in a diner, and he had with him a copy of this book you see over here. It says Electrodynamics. It's by the German Arnold Sommerfeld, who Sommerfeld had Heisenberg, Pauli, and 2 other Nobel Prize winners for students. That's who Sommerfeld is. Okay, he was a giant in terms of bringing great physicists forward. And in this book, while we're having coffee. He shows me now look on the pages here. He opens it up. On the left-hand side of the page, he shows Maxwell's equations. They're all there. Now, on the right-hand side of the page, he says, now here are the equations of fluid dynamics for a perfect, meaning a frictionless, incompressible fluid. A fluid is made up of atoms of some sort, but they're frictionless as they rub against one another and they can't be compressed. Okay, so the equations are basically the same, except that there's extra terms in the equations for fluid mechanics based on the density of the fluid. So forget that you know anything, just go ahead and take those terms and stick them in to Maxwell's equations, add them in, and the density of what you're talking about here is something called the ether. So the ether was postulated as something that allowed energy to propagate through space. And there were a lot of work done on this in the 1880s, 1890s, and so forth, but it was all dropped for some reason. No one is really clear as to why. But if what he'd done in the margin of his book was he'd carried out a perturbation analysis where he looked at the equations for electromagnetism with these terms for the density of the ether included, and he expanded them on a power series. So the 0th order term is the ether density to the 0th power. Anything to the 0th power is 1. And when you look at that, those terms are Maxwell's equations. Okay, so we're looking good. But then when we include first order, the density to the first power and the density to the second power, first and second order terms, what you see is you end up with terms describing the strong force that bind protons in the nuclei of atoms. And remember what Faraday had discovered was that opposites attract and likes repel. But in the nucleus of the atom, on very, very short scales, the protons are all positively charged, and the strong force flips these things. They now attract one another. They don't repel one another. That comes out of this. And the weak force is inside atoms. The neutrons split into a proton and an electron, and the proton stays there, and therefore the nucleus has one extra proton in it. It becomes what's called an isotope of that material, and the electron goes flying off. And then finally, so we've described the strong force, the weak force, all the equations of electromagnetism, and finally, the change in the density of the ether is what we call gravity. Okay, so when you have a very rapid change in density, there's a lot of gravity. When there isn't a lot of change, there's very little gravity, which matches intuitively what Einstein did in general relativity. So that was an interesting cup of coffee back in 2005.
I just want to say one thing. Ether was considered kind of a woo-woo alchemical thing. And so I think that was part of why it was poo-pooed. Because it was the 5th element. And
Well, no one could
there was
come up with
fire.
experiments that would
Right.
show that there was an ether there, except for Tesla. Tesla did this in the 1890s, but then he realized what he was onto and how it was actually probably far too dangerous to share with the rest of the world. The rest of the world was pretty ugly place.
How it would be used.
So
Well, one thing that comes to mind is that it's a way of codifying, maybe it's a phenomenon as a thing, maybe it's an event and it's being described as a substance, the same way a particle or a wave is being conceived of as one thing or another thing, when maybe it's just a type of behavior, or a way of measuring the behavior that makes them seem like two different things that exclude each other, but maybe it's just our conceptual way of measuring it.
Yeah, I would
and
say,
understanding it.
yeah, if you talk to physicists today, they would say, oh yeah, the space itself is made up of discrete particles or a foam, and we call that the ether, and it's accepted now that that's what it is.
Right.
But the actual consequences of this ether, in terms of what Sommerfeld did, they're not aware of. It's not widely known that you can get all of these uh, forces, the forces of electromagnetism, strong force, and the weak force and gravity, all come out of electromagnetism, and that's not a minor thing.
I was a kid and I said I thought that magnetism and gravity were related. People, no, not really.
Yeah, no,
But it just
they
made
were.
intuitive sense to me.
Yeah.
So,
So here we've
yeah,
got, I think you're going to have to go. I don't know, it's going to stay there. Okay. So today we're also, the reason why we put this class together was people don't realize that there's a real major crisis in physics for over 100 years. And what happened is that in the 1920s, physicists came to realize through measurements made by optical telescopes that they'd only been studying 5% of the universe, and the other 95% was unknown, unseen, or dark. And that's not a minor miss to miss 95%. There was an individual over here, Vesto Slipher, who in the 1910 timeframe at Lowell Observatory in Flagstaff, Arizona. This is the same place where this guy saw canals on Mars, and then he realized that his telescope was too blurry and they weren't really canals. But on the other hand, maybe they were canals. Maybe he did see something. Anyway, the same observatory, this guy observed that there were clusters of smudges that he actually observed were clusters of stars. The telescope was good enough to resolve them, and he saw spiral nebulae, which became galaxies. And not only did he see these clusters of stars in these spirals, but he detected that they were moving away, that they were shifted. Everything was shifted toward the red part of the spectrum, toward the long wavelength side of things. And this provided the first evidence that the universe was expanding. The 1920s, Edwin Hubble, who's shown here, up here, and this is a telescope that he used at Mount Palomar. He confirmed these observations, and he actually was able to estimate the rate of expansion of the universe, which he shared with Einstein, and Einstein included it in his equations for general relativity. And then down here, this guy here is Fritz Zwicky, who was also at Mount Palomar, and he took a look at doing some calculations. Let's say we got a galaxy and it's filled up with 100 million stars, and they each have the mass of the sun, and they each attract one another by gravity. So there's an inverse square law. Then what can we say about this? And he determined that if that's all we saw, that all of these galaxies would fly apart, that none of them were stable. And he said, okay, the only way for them to be stable is there's got to be additional matter there, except I can't see it. And so he called it dark matter. And that makes up 27% of the universe right now by the best estimates. And then finally, in the 1970s, this woman, Vera Rubin, did all kinds of observations beyond what Fritz Zwicky had done that confirmed that yes, 27% of the universe is dark matter, and that means that 68% is dark energy, the energy that's expanding space itself, that's driving all of the galaxies away from one another. Remember, they're not moving, the space itself is expanding, so each little piece of foam of space expands a little bit, and collectively that pushes everything apart, which takes us up to
And
Ron.
that's something that the Hindus
Yeah,
talked about.
yeah, everybody.
millennia
And because
ago.
things are flying apart, this led people to say, well, then they must have all started off at one point. If they're, and they trace things backwards, and they determined maybe the book of Genesis was indeed correct, which we'll come back to. So this takes me up to interacting with Ron. Ron had been doing observations since at least 1990 till he passed on in 2019. And I just summarized some of them here. This picture we came up with of a 24 spatial dimensional universe and two dimensions for time. He had information everywhere, coding all these particles. So we created this figure here, showing what's going on, the compactified dimensions, which are shown here, and then the notion of symmetries, where we have 26 symmetries, which appear to match the 26 dimensions that we have here for our universe. So this is really fundamental work that Ron was involved with that provided a lot of grist for the mill for theoreticians going forward in time.
We spent a wonderful snowy weekend developing these two charts together. And it was only when we were done that I realized I had unconsciously picked the color scheme of this Calabi-Yau manifold.
Mhm.
But we this is like, we're a couple of nerds. We enjoy spending our time doing and modifying it. And I would, put on my copy editor hat and ask, well, do you mean this? Would this be a better word? Would this, explain that, and trying to make it as symmetrical as possible. And that interchange helped us lay it out this graphically and clearly with this same color palette. It was
Right.
not quite synchronistic because I had seen that, but that's why it worked out that way. And if you really drill down into this, carefully, you can see this isn't just some new age formulation or something. It's not at all casual. It's very, very intricate. And the term dark matter, right now, I think it's kind of like the geneticists who described the code that they didn't really understand.
Call it junk DNA.
Right, they called it junk code. That's until they understood more about it. So we're just calling it dark matter and dark energy, while it's kind of a placeholder for more detail to be filled in.
Yeah, the one of the things Ron observed was that the dark matter has 10 strings, and energy resonates inside those 10 strings for all of these fundamental particles that are in the physics taxonomy. But dark matter, they only have 5 strings. So while they're vibrating like crazy, they're not nearly as energetic as the matter subquarks. This is an example of a subquark. And the other thing is there's no charge. So the dark matter simply forms a subatomic chemistry where these little subquarks all basically form branching trees or ferns of these things, but they're very, very small. And so by being very dense, they can end up creating a lot of mass, but in a space much smaller than the space that you would think of for matter, for things like stars. And that's what makes things interesting. The other thing Ron observed, that this dark matter is in one of two states. It's either quiescent, so just sitting there inert because it doesn't have anything that makes it want to vibrate. It needs something like a thermal source or something that'll jiggle it to give it some energy to come to life. and it is sentient at all times, but it's just asleep. It's quiescent. When it gets some energy, then it becomes sentient and it comes to life and it does all kinds of things. And in fact, it fills up all the stars that we see around us, for example. But the geometry of it, because there's no charge, you end up with something very different than what we know of as chemistry. So a lot of fundamental observations here. This just shows Ron came up with pictures of the electron, and he was able to do this because he could stop it, which other people couldn't do. Leadbeater and Besant could do this, and so they did their picture of what something like an electron looks like. And to me, the pictures that they have and the pictures that Ron came up with are identical. And there was another guy in the 1880s, Babbitt, who came up with some pictures, and they look similar there too. You know, for now, we actually have a picture of an electron. Um, if you go into any physics book and look, you'll never find a picture of an electron. You might find a picture of a cloud where the electron's vibrating like crazy, but none of them have been able to stop the electron the way that Ron or Annie Besant and Charles Leadbeater did to get these sorts of pictures.
Do you know if he was aware of their work or not?
Oh yeah, yeah, Bruce. Well, Ron was aware of Annie Besant and Leadbeater. Well,
Yeah, I think so.
yeah, I asked him about this. Yeah, he was asked him about it early on, and yeah, he had looked at that and he tried to duplicate what they'd done, and he actually did better than them. One thing that was not obvious, whenever Leadbeater and Besant would do anything, like for example, take hydrogen. Hydrogen is the simplest example. It has one proton in its nucleus and one electron running around it. They could not observe a single hydrogen atom.
Yeah, they paired them.
They had to always look at pairs. So they looked at two hydrogen atoms paired together. Ron was able to look at a single hydrogen atom and look at the single proton and the single electron running around it. But they couldn't do that. But having said that, that just meant that all their numbers that they came up with for elements and how many protons were there, he just had to divide by two because they always had twice as many. So the next thing that we came up with here, besides what Ron observed, is David Clement, who we talked about a couple of weeks ago, looked at a photon. Now, it turns out a photon is actually, what carries the energy in electromagnetism. So it's a discrete particle. But what does it look like? Well, it looks like two tetrahedrons, one pointed up and one pointed down, that intersect one another. But it's vibrating like crazy. So when you look at a photon, it has all kinds of energy emanations around it. But I don't recall that Ron was ever able to stop a photon to go draw pictures like this, but I knew that he was aware of it at some level, that a photon really is looking something like this. But when it starts to vibrate, you just have a ball of light sitting there going crazy. And then the other thing that goes with it is the photon is coated with these blocks of information. So whatever it is doing, it's doing it according to these laws that govern everything, the collective unconscious that's all around us. This thing about information is probably one of the deepest things that Ron came up with, because he used this in this to explain this double slit experiment, where you shoot electrons at a single slit and they go right through and they have a line of electrons hitting a foil behind the slit. And then you put in two slits close to one another and you end up with not two lines of electrons, but a wave pattern of interference beyond the two slits. So the electron is now behaving like a wave. And whenever he looked at this, apparently the electron was able to, by scanning, by the information blocks on the electron, it was scanning the things around it. As soon as it detected there were two slits or one slit, it became a wave or a particle, depending upon the circumstances. And this is truly amazing. But the thing that this information does is it allows you to control all of these different forces that are around you, which is how Ron was able to get into this through his consciousness and manipulate and stop an electron from vibrating, which is, truly amazing, but only under deep meditation. Now, as an aside, I'm going to talk about complex numbers, and this comes out of left field. So let's just
Well, you refer to them later, so this.
yeah,
I
we're
suggest
gonna
you
do it in the next chart. But it turns out that if we do real numbers, we miss out on some things. So, for example, suppose we're trying to solve an equation x squared equals 4. What are the solutions? Well, somehow we think if it's x squared, there ought to be two solutions, and the two solutions should be what? +2 and -2. So +2 times +2 is 4, and -2 times -2 is 4. So I have two solutions. Great. Now here's the problem. Suppose the equation is x squared equals -4. -4. Now I don't have any solution unless I assume, well, I have x equals +2 and -2, but they're each multiplied by the square root of -1, whatever that is. So this leads to the notion of extending the numbers that we're familiar with to what are called complex numbers. So there's two parts to the number. One is a real part, which was labeled here on this axis as A, and then on the vertical axis is something labeled B, but B is actually multiplied by the square root of -1. I is the square root of -1. So this complex number Z, which is A plus B times square root of -1, is a perfectly run-of-the-mill complex number. And we can now solve all of these quadratic equations. For example, x squared equals -4. We can now solve it if we allow ourselves to use complex numbers. Or we can add x squared plus 7x plus 3, and we'll come up with some other thing. So it goes. So
this whole relationship then becomes conceived of as a number.
right.
But it's really like a hypothetical
Yeah,
relationship.
it happens to have two pieces to it. It's a single complex number, okay, but it has two parts, a real and imaginary part. So one thing to keep in mind here, since we've got this picture, is if I just had A down there and B was 0, then I would be down there on this horizontal axis. But if I multiplied A times I times the square root of -1, then I would be straight up on the vertical axis, up by A. So multiplying by the square root of -1 effectively rotates things by 90 degrees. It turns things perpendicular to one another. Little trick to keep in mind. So this leads to what Ron came up with for these hidden or compactified dimensions. And in particular, if we take this plane here, which has two dimensions to it, so you could think of this as being a real part and an imaginary part, one going one way, one going the other. But it's two real dimensions, but it's only one complex dimension. And now I wrap that around, for example, my x-axis that I have in the space that I'm operating in. So I have two dimensions wrapped around the dimension that I think of as x, and I repeat that for another two dimensions wrapped around y and another wrapped around z. And you end up with being able to have all of these compactified dimensions and remember there's 18 of them, so there's 9 pairs of 2. They're all wrapped around 3 times each, the x-axis, y-axis, and z-axis. They're all there. They kind of beef things up. But the problem with it is this physicist here, Oscar Klein, did some calculations, and he figured that it's probably on the order of 10 to the minus 35 meters. We have no way today to measure anything remotely like 10 to the minus 35 meters. If we could actually start to see these things. Now, Ron could sense them, but I don't think that he could actually see them. But he could see that they were there, that these hidden dimensions were actually beefing up what he was actually sensing as reality. So that's one question that we dealt with. Where in the world are these compactified dimensions? And then Ron also looked at the 24 spatial dimensions and ended up with the idea of there being these holes, 8 holes total, and the 18 compactified dimensions. So that leads us to really only 10 dimensions, or the 10 Sephiroth of the Kabbalah.
Which you don't have a picture of.
I have a picture of the, I don't have a picture of the Kabbalah, no. Or the Tree of Life.
Right.
I could put that in.
You should have that.
Right. And what goes with this is that time is actually a complex number. Sounds crazy, but time that we deal with itself ends up being a real number, but we live in a world of free will. So what this means is in quantum mechanics, it was realized that it's possible to have a description of quantum mechanics where everything occurs, every possible thing that you can imagine occurs. Every time there's any change whatsoever, where an electron shifts from one energy level to another, wherever it is, that immediately creates a new timeline, a new universe, a new world line. And so there's trillions upon trillions upon trillions of these being connected, created all the time. And that's what's called the many worlds interpretation, or the many timelines interpretation. And because we live in free will, the free will can shape these things so that some of them coalesce together, and some patterns become much more likely than others. And when we actually go and live these things, we go through in our life and have a complete record of this. Now that's what's called the Akashic record, and that's kept by your soul. And that's the imaginary time dimension. Remember, we said time has 2 dimensions. The real dimension is the one that we see, but the Akashic record, or the Akashic thread, is actually in the perpendicular space of time to our time, and everything is recorded there. So when you pass on, the Akashic record that's played before you, so you can see your life, is all recorded there. It's all on this one thread. Here's the threads up here out of the fabric of the Akashic record. Here's the many, many timelines down here that are being created all the time to create everything. So just to keep that in mind.
Is
And
it a word for imaginary? Is it possible to think of it as hypothetical?
no, it's very real.
It's okay.
Yeah,
It's actual.
yeah, yeah. Yeah, it's, it comes about naturally in algebra for trying to solve quadratic equations, and you need the same thing for being able to solve 3rd and 4th order equations. There's no general solution for 5th order or higher. So, you need it for all of those sorts of things. And it's very natural to go use it there. Now, the time that we're talking about here, we have the space that we live in, which is X, Y, and Z. And now we have a problem that time is in seconds. So we need to convert seconds to some measure of distance. X, Y, and Z are in meters. Okay, so if we multiply time by the speed of light is meters per second, time is in seconds, so I get meters. But I have a little wrinkle to it. I have to remember to stick in the square root of -1 because time is perpendicular or orthogonal to the three spatial dimensions that we see. We don't have any way to actually measure time per se. Time is, we can measure length, width, and breadth. That I can do. But when it comes to time, the only thing I can do is get a clock and say, oh, this took this many seconds, but that doesn't really measure the time itself. It's just an instrument that's doing that. And
I
so,
don't think it's linear the way we think of it.
oh, no, well, it's not because of these things here. You're
Right.
branching off into all kinds of different directions. That's due to free will.
And it warps, right?
Yeah, it can go any which way. There's all kinds of things going on that are local perturbations, and the free will shape it to come together locally in certain ways, and other times and places it'll do different things. So you can see that time is very different than space here in dealing with any of these things. And the related space for dark matter, we simply took the coordinates x, y, z, and ICT for our space, and we multiplied by square root of -1. So these are all rotated away 90 degrees from the 4 that we have here. And that seems to work. And that leads to this Akashic thread, which is the timeline that each of us lives on. So to summarize, we talked about the tree of life of Kabbalah, which has 10 nodes or Sephiroths, and that's critical. Stephen Phillips, who's a British theoretical physicist, independently reached the same conclusion and has a website and some books and papers on this about the actual 10 nodes of the tree of life. And then we come back to Jesus of Nazareth, and he spoke of a Trinity. So the Trinity he's speaking of, he was living here in this matter space here of 3 dimensions with time, and therefore this is where you would see the sun. So the Holy Spirit he was talking about has to be over here, and the Father that he was talking about has to be connecting the Son and the Holy Spirit together. Or to put it differently, we should have turned this picture around to have other things have the higher realms on top and not on the bottom. But we get the idea. And the Unitarians, by the way, were created in the 1600s in the middle of the Reformation because there was a big fight saying that there was really just a Trinity, and the Trinity had a Father, a Son, and a Holy Spirit. But the Unitarians said, well, there's really just one. Well, you can see that both are right. There really is just one universe that has these 24 spatial dimensions. Here it is. But we can break it out into subspaces, and the subspaces could be interpreted as where the Father, Son, and Holy Spirit reside. But that gets to be, you have to ask yourself, why are you doing this? In the 1600s, people got killed, burned at the stake for coming up with the wrong answer. I mentioned briefly that physics hit the wall 50 years ago. So 50 years ago, physics came up with what they called the standard model of elementary particle physics. There's an electron, and the electron has 2 related states, a muon and a tau particle. But actually what Ron observed was there's 3 holes in the compactified dimension. So the electron that's here resonates into this one and into this one. These are just resonances of the electron here. Similarly, there's an electron neutrino here, and that has two variations, but those are again resonances of what this one is. So neither of these are really they're there as particles, but these are the two key ones, and it's the geometry with the holes that creates the other ones. Similarly, for these quarks, there are resonances that are occurring here. Now, the key thing is all of these things here, all of these bosons arise out of electromagnetism. So they really all are due to photons resonating at different scales to produce the strong force, the weak force, and gravity. And finally, there's the screwball one that was discovered in 2012 called the Higgs boson. And that simply starts off when the universe first starts, that is zero. And it controls the amount of mass for each of these different particles. Each of these particles has a mass that is proportional to the mass of the Higgs boson. Well, the Higgs boson is zero mass, then all of these have no mass. They don't exist. But when the Higgs boson kicks in just after the universe gets going, and it then creates masses for all these particles. And there similarly is a Higgs boson that Ron observed for dark matter. And dark matter again has four types of these subquarks here and so forth. And so the dark matter Higgs boson creates the scaling for the matter that's there. Now, there's really been no advances in this since 1975. This is all that's changed is they've been able to measure things now up to, and some of these things have been measured to 13 significant figures. And to measure something to 13 significant figures is truly mind-boggling. That you can actually have a theory that would predict that precisely what's going on to 13 significant figures.
So the idea of the Higgs boson is that it's a scalar.
It's a scalar.
For
It's
everything
not,
else.
while it's called the boson, it's everywhere. It's throughout the entire universe, and it controls the mass of all the particles, of all the matter, and the similar dark matter Higgs boson controls the mass of all the dark matter subquarks.
So without that, we're talking about how the angels are dancing on the.
Right. It creates all the
Yeah,
physics that's
right.
going on, makes things interesting. So here we are, and we're already up to say 9 o'clock, and this is a different topic, which is cosmology. So why don't we break it here, and we'll pick this up next time. And Marjorie has some stuff that she can add too. And
Well, I think it's good to get this all in there first, and then maybe I'll blend a little about the ideas around Mercury retrograde
sure,
and how that works, because we know it's an illusion, but it seems to have some impact.
right.
And I think if we could bring it together with the double slit experiment, we might really have an explanation. And that's a part 3 of an essay that I've been working on for a couple of years that I'd like to do. So maybe if we have this dialogue, we'll move
Yeah.
that a little
Yeah,
further.
we'll try and do it. I mean, just to show you here, I pushed Ron. He went back to the start of the universe, and I kept telling him to look for the Higgs boson and the dark matter Higgs boson, and he spotted both of them, which was no small accomplishment. Okay, but what happened is you should think of the universe at that point being kind of a primordial egg, and all of a sudden it starts to exponentially expand. This expansion is called inflation, but it's expanding at this incredible rate, something like 30 orders of magnitude in virtually no time. And so but then the inflation stops. Well, when it stops, our universe is then created, but the rest of the egg is still there. The rest of the egg is still there. So the rest of the egg is still expanding. So that results in the creation of another universe. And then that piece stops, but the rest of the egg is still there. So that keeps expanding. So there's clearly billions upon billions of universes out there that have been created from this moment of expansion, not just ours. It's called the multiverse. To have something to talk about. And the other thing that Ron observed, and I pushed him on this, was that there was no bang. There was simply an expansion that occurred. I said there isn't any, nuclear fireball, no.
These are his illustrations.
Yeah, and this is a picture showing what he thought of as inflation occurring and so forth. When he did some sketches of, which we'll come back to. So really amazing work trying to encompass all of these different things and create some coherent theory. And this led me to believe that it really isn't physics that's the most fundamental part of all this. It's actually mathematics or metamathematics that lies above all this, that controls everything. And with that, I think we'll quit.
I'd just like to add that the Hindus talked about this as a cyclical contraction and expansion
Right,
that they likened to the universe and all the potential universes breathing. It's like exhaling and inhaling,
right.
but that it's alive and it's
Yeah.
always going through, in Kabbalistic terms, this constant creation and recreation.
It appears that the universe is actually much older than we think. And the only way that I could think of to have this sort of background primordial cosmic radiation that has been detected is that one of these other multiverses might have collided with our universe. Okay, because Ron was very adamant there was no explosion that took place, yet there is this primordial cosmic background noise. So one mechanism for creating that is to have two universes combine or smash into one another. That would definitely create a bang. I wouldn't want to be around for that, but I wasn't. So with that, any comments, Bruce?
No, wow.
No, Ron did an amazing job. I'm just trying to package it so that we can take away some lessons. That's all. He was there, and I'm just trying to wrap some structure around it.
Okay.
I love the idea of him racing to complete this work and communicate it, as he knew his life was finite, as he knew he was running out of time, but he was, working frantically to
Yeah, in the last
record
year,
it all.
he went to the hospital, what, 2 or 3 times, and like the last time was he didn't come out,
That's right.
So
We just need 10 more meditators like Ron.
yeah, no, he clearly got a lot out of the book.
Yeah.
So I'm looking forward to reading it.
Right.
Okay, have a good weekend. We'll catch you
Okay.
next week.
Yeah.
Bye.
Bye.
So to be continued to some extent.